Hey guys, it's Miss Johnson here, and I'm here to bring you your video for linear programming. We're talking about linear programming today. Linear programming is a process that farmers and businesses use in order to optimize something, either finding the minimum of their costs or finding the maximum of their revenue or profits. That's when we set up a linear programming model and we plug it into an optimization function or an objective function. Okay, so we're going to be setting up linear programming models today. Now, the reason that we're looking at this today is because linear programming is really just a system of inequalities. It's a system of inequalities that we put together on a coordinate plane, and the shaded region is called the feasible region, and that is the region that gives us the optimized function. Okay, so here's what we do in order to work with a linear programming model. We have a system of constraints, and that's the linear inequalities, okay? Linear inequalities of the function. They can be minimized or maximized, and we use an objective function in order to figure out where the minimum and the maximum is. So our task today is to do these three things. We need to graph the system of inequalities or graph the system of constraints, find the vertices of the constraint system, and evaluate those vertices in the objective function to get the minimum and the maximum. You're going to see an objective function that looks something like this, f of x comma y. That's our notation for the objective function, and then whatever it equals over there. Okay, so for example, this one over here, you've got three inequalities that are in the system. Those are the three constraints, and those three constraints made up these three blue lines and gave us these three vertices. So these are the three vertices of that feasible region. The feasible region is inside of it, and we would plug those vertices into the whatever the objective function is to figure out the min and the max. So let's take a look at example 1 and see if we can figure out what we're working with here. It says graph the system of inequalities, name the coordinates of the vertices of the feasible region, and find the max and min given the objective function. So first thing I want to do, graph the inequalities. This one right here, x is greater than or equal to 1, that's going to be a vertical line at 1. That's a line that has an undefined slope. So I'm over here at positive 1, and I want to put a vertical line on that coordinate plane. So here's a vertical line at positive 1, and it is a solid line, so I'm okay to draw that solid line in. All right, so there's that first one. The second one, y is greater than or equal to 0. That one's a horizontal line. That one has no slope. So we have a horizontal line at 0. So we're at 0, we didn't go up or down at all, and we want a horizontal line. And there we have it. And then the last one, now think back to graphing lines and inequalities. We need to solve for y here, so I'm going to subtract the 2x and move it over to the other side so that y is alone. I have y is less than or equal to negative 2x plus 6. So that means I have a y-intercept up here at positive 6, and then my slope is negative 2, so that's down 2, right 1. Down 2, right 1, down 2, right 1, and so on. And again, this is a solid line. So here's my line for that one. Excuse me. Didn't go quite through the points. Let's slide it up a little bit. There we go. That's a lot better. So there are my three lines. Now, what we want to look at is what are the vertices of the feasible region. So our feasible region is this thing right here. In other words, where do the inequalities intersect? And it's at those 3 points, with the shading being in the middle. Now let's take a look at what those vertices are, because that's our next task. We have to name the vertices. So the vertices for this feasible region look like 1, 0, 3, 0, and this one up here looks like 1, 4. Okay, so now we've got the graph, we've got the feasible region, we've got the three vertices of the feasible region. Now we need to use this objective function. So we need to come back to this objective function and we need to figure out where's the maximum value and where's the minimum value. So we do that by taking the vertices and plugging them into the objective function. Some people call that the min and max function because that's what it's doing. It's finding the min and max. So if I plug this first one in, that means I have f of 1 comma 0. Now remember, that's just notation. We don't do anything mathematically with it. It's just notation. So I have 3 times 1 plus 0, which gives me 3. The second one is 3 comma 0, the function at 3, 0. That would be 3 times 3 plus 0, which equals 9. And the last vertex would be 1 comma 4, so that's 3 times 1 plus 4, which gives me 7. So I can see from looking at these three values that the minimum value that I'm looking at is 3, and the maximum value that I'm looking at is 9. Okay. Now this is a pretty simple example to get started with. These are pretty easy lines to graph. Our examples do get a little bit more tricky when they apply to real world stuff, but we'll just start with some simple examples. So then let's take a look at example 2, and we can work with that one. So in example 2, now I'm given the three constraints. X is less than or equal to 2, 3x minus y is greater than or equal to negative 2, and y is greater than or equal to x minus 2. So I'm going to get you guys started here and help you put these on the graph, and then I want you to figure out the objective function for these, the min and max. So remember that these need to be solved for the variable. This one's going to be a vertical line at 2. So I'm over at positive 2, and I have a vertical line right there. And then the next one, I need to solve for y there. So if I take 3x minus y is greater than or equal to negative 2, subtract the 3x, I get negative y is greater than or equal to negative 3x minus 2. I need to divide by negative 1 and think back to inequalities. When we divide by negative 1, that means we have to flip our sign. So it's y is less than or equal to positive 3x plus 2. So if I graph that one, I'm going to go up to a y-intercept of positive 2 and then go up 1, 2, 3 and over 1. Or we could go down 1, 2, 3 and back 1. Down 1, 2, 3 and back 1. Or up 1, 2, 3 and over 1 here. Okay, so there's our line for that one. And then we need to graph that last one. Y is equal to, there's the blue line. Looks pretty good. And then the last one, y is greater than or equal to x minus 2. So that means I have a y-intercept of negative 2. And the slope is 1. So up 1 over 1, up 1 over 1, up 1 over 1, up 1 over 1. Or down 1, back 1, down 1, back 1. And so on. And there's our line for that one. So then let's go ahead and see if we can figure out where the vertices are. That's our next part of this. And it looks like when I'm looking for the vertices, it looks like I'm right here at negative 2, negative 4. And then I'm up here at 2, 8. And right here at 2, 0. So those are the three vertices. Now I want you guys to stop the video at this point and I want you to plug them into the objective function to figure out where the min and the max are using those three vertices. That's going to stop our video for today. Thanks for watching and we'll come back and finish tomorrow. Have a great night.